December 12, 1942. Near Melun, France, Lieutenant Paul Flickinger's B-17F Flying Fortress Wulfe Hund descended through the overcast, 2 engines dead, another failing. The 303rd Bombardment Group aircraft had been savaged by German fighters after bombing the Rouen-Sotteville marshalling yards. Now, with fuel exhausted and nowhere to run, Flickinger set the bomber down in a French field, delivering to Nazi Germany an intact example of American industrial might that would shatter every assumption the Luftwaffe held about their enemy's capabilities. Within days, the captured flying fortress arrived at Rechlin Test Facility in Mecklenburg, hastily repaired and bearing fresh Luftwaffe crosses over its olive-drab paint. This was not the first B-17 the Germans had examined. Crashed specimens had been pieced together since October 1942, but this was the first they could fly, test, and truly understand. What followed over the coming months would be the most profound psychological revelation of the air war, the discovery that American mass production had already won a victory that no amount of German courage or skill could reverse. March 17, 1943. The morning mist lifted from the pine forests surrounding Rechlin as Luftwaffe test pilot Hauptmann Heinrich Beauvais performed the first German flight of the captured B-17F senior officers had assembled from across the Reich to witness this examination of American capability. Among them stood Oberst Adolf Galland, General der Jagdflieger, whose presence underscored the importance of understanding this enemy that was appearing in ever-increasing numbers over German territory. Galland had already seen the initial examination reports from crashed B-17s the previous October. Then, as a colonel and chief of day fighter squadrons, he had stated, "It unites every possible advantage in one bomber. Firstly, heavy armor, secondly, enormous altitude, thirdly, colossal defensive armament, and fourthly, great speed." Now, watching the intact aircraft circle Rechlin, he would discover these advantages were merely the visible portion of a far more devastating truth. The B-17F stood on the tarmac like evidence at a trial Germany had not realized it was attending. Its wingspan stretched 103 feet, dwarfing the twin-engine bombers that formed the backbone of the Luftwaffe. More telling than its size was its condition. Despite battle damage and a forced landing, the aircraft remained fundamentally sound. German bombers suffering similar damage would have broken apart. This American machine was built to survive. General Feldmarschall Erhard Milch arrived from Berlin, where bomber production was falling catastrophically behind schedule despite his desperate efforts. Milch had examined the first crashed B-17 the previous October, afterward telling his staff, "The Reichsmarshal told me that there is no cause for anxiety about the American aircraft, and that, 4-engined though they may be, we can contemplate future equanimity." I told him that I do not agree. He had then added prophetically, "These are worries I just can't get over. We have got to accept that one day the enemy bombers attacking Germany will be flying at altitudes of 28,000 or 30,000 feet. Now, seeing an intact specimen, his worst fears materialized before him. The inspection team climbed through the rear fuselage door, and immediately the contradictions to Nazi propaganda became apparent. This was not the crude, hastily assembled machine they had been told American factories produced. Every rivet was flush, every panel precisely fitted. The interior was painted with zinc chromate primer, a corrosion protection German aircraft lacked due to material shortages. Cables ran through protective conduits. Hydraulic lines were color-coded for easy maintenance. This was sophisticated engineering designed not for individual excellence, but for multiplication by thousands. Oberingenieur Wilhelm Dornier, examining the bomb bay, discovered something that chilled him. The bomb shackles were standardized, completely interchangeable. A damaged shackle could be replaced in minutes with parts from any B-17 in the American inventory. German bomb shackles were hand-fitted, each slightly different, requiring skilled technicians for installation. This single detail contained the DNA of Germany's defeat, complete standardization enabling unlimited production. In the radio compartment, Feldwebel Kurt Reinhardt from Telefunken stood transfixed. The SCR-287 liaison set, SCR-211 frequency meter, and SCR-522 command radio were modular units, designed as complete assemblies. German aircraft required 3 hours to replace a radio. This American system could be swapped in 30 minutes. But it was the quality that stunned him. Each radio contained dozens of vacuum tubes, precision resistors, and capacitors, components Germany increasingly struggled to produce. The Americans had equipped this single bomber with electronics that would have supplied 3 German aircraft. Major Wilhelm Herget examined the defensive armament with professional interest. 13 Browning M 2.50 caliber machine guns bristled from the fuselage. The nose guns, cheek guns, dorsal turret, ventral ball turret, waist guns, and tail guns created interlocking fields of fire with no blind spots. The ammunition load was staggering, 6,380 rounds aboard, 5 times what a German bomber carried. Each gun was fed by metallic link belts, reusable and reliable. The Luftwaffe still used fabric belts that deteriorated in weather and jammed frequently. In the cockpit, Galland sat in the pilot's seat, studying the instrument panel. 56 instruments and gauges faced him, each clearly labelled in English. The Sperry artificial horizon was more precise than anything Germany produced. The Minneapolis Honeywell C-1 autopilot could fly the aircraft for hours without pilot input, reducing crew fatigue on long missions. German bombers required constant manual control, exhausting their crews before they reached their targets. The 4 Wright R-1820 Cyclone engines drew particular scrutiny. Each produced 1,200 horsepower, built with tolerances German factories could achieve only in small quantities. The turbochargers, manufactured by General Electric, maintained engine power up to 25,000 feet. Germany's turbocharger development had failed repeatedly, forcing operations at lower altitudes where fighter interception was easier and deadlier. The fuel system revealed American assumptions about resources. The self-sealing tanks held 1,700 gallons of 100-octane fuel, a grade Germany could barely produce in laboratory quantities. The entire German aviation industry operated on 87-octane fuel, limiting engine performance and range. Here was an advantage that no amount of pilot skill could overcome: fundamental chemical superiority. Every component bore manufacturing stamps revealing continental industrial mobilization. Parts came from Seattle, Wichita, Buffalo, Burbank, San Diego, Fort Worth, Tulsa, Nashville, dozens of cities across America. This was not one company building bombers, but an entire nation transformed into an aerospace factory. The oxygen system supplied 10 crew positions, each with main and backup supplies, regulators at each station, and telltale indicators showing system function. The Germans had lost entire crews to hypoxia, men dying without knowing they were suffocating. The Americans had engineered away this problem with redundancy and indicators, accepting weight penalties for crew survival. The armor protection was comprehensive, not selective. The pilot and co-pilot sat behind 500 pounds of armor plate. The bombardier was protected by inch-thick glass panels. Critical control cables ran through armored conduits. German aircraft carried minimal armor, saving weight for bombs and fuel. The Americans valued their crews enough to carry a ton of armor into combat. Test flights over the following weeks revealed operational advantages that translated into strategic superiority. The B-17 was stable, forgiving of pilot error. The controls were hydraulically boosted, requiring minimal physical effort. A pilot with basic training could fly this bomber effectively. German aircraft demanded experienced pilots, a resource already growing scarce as losses mounted. At 25,000 feet, the turbochargers demonstrated their value. The B-17 maintained speed and maneuverability where German fighters struggled to climb. The heated suits and oxygen systems functioned flawlessly at temperatures that would have incapacitated German airmen. This was strategic bombing made practical, the ability to operate above most defenses, day after day, by hundreds of aircraft. Hans Jescheneck, Chief of General Staff in the Luftwaffe, had tried to maintain optimism after the October examination of crashed specimens, declaring, "We will fetch these 4-engined bombers down just as quickly as the twin-engined ones, and the loss of a 4-engined bomber means a much higher loss to the enemy." Such optimism was crumbling before the reality of what an intact B-17 revealed. The navigation equipment included innovations Germany hadn't imagined in mass production. A radio altimeter accurate to 10 feet allowed precise low-level flying in darkness or bad weather. The Bendix radio compass provided accurate bearings regardless of visibility. German aircraft relied on traditional navigation methods requiring extensive training and producing variable results. Intelligence reports accompanying the captured bomber painted an even more disturbing picture. Boeing's Plant 2 in Seattle covered 1.7 million square feet. Douglas in Long Beach occupied 1.4 million square feet. Consolidated in San Diego sprawled across 1 million square feet. Each plant was larger than all German bomber production facilities combined. If each produced just one bomber daily, simple arithmetic suggested 1,000 bombers monthly. German production of all aircraft types barely reached that number. The manufacturing philosophy revealed by the B-17's construction was alien to German industrial culture. Americans had designed for mass production from the beginning. Every part was numbered, catalogued, specified in drawings that any factory could use. German engineers designed for performance, treating production as a secondary problem. It was too late to transform an entire industrial philosophy while under bombardment. By April 1943, Wulfe Hund began touring German fighter units for tactical familiarization. Pilots studied it, learning vulnerabilities, but also absorbing a deeper message. America possessed industrial superiority that tactical success could not overcome. The defensive firepower was murderous, the structural strength remarkable, the system's redundancy impressive. Oberstleutnant Egon Meyer, commanding 3JG2, developed head-on attack tactics after studying the B-17's defensive arrangements. But this required exceptional flying skill, split-second timing, and acceptance of high losses. The Americans had forced the Luftwaffe to adopt desperate tactics simply through the defensive capabilities of their bomber. The workshop at Rechlin attempted to manufacture replacement parts for the B-17, testing German production capabilities. The results were humiliating. German craftsmen could duplicate individual parts, but not to the precise tolerances that made them interchangeable. A German-made engine cowling wouldn't fit properly. German-made control cables were slightly different in diameter. The standardization that enabled mass production required industrial precision Germany had never achieved. Production statistics emerging from intelligence sources were devastating. Boeing alone was producing 16 B-17s daily by mid-1943. Douglas and Lockheed Vega added more. Combined production exceeded 500 aircraft monthly. The Luftwaffe was destroying 60 to 80 per month. The mathematics were irrefutable. America was building faster than Germany could destroy. The materials situation was equally insurmountable. Each B-17 required 7 tons of aluminum. America's aluminum production exceeded 2 million tons annually. Germany managed 420,000 tons. The copper in a single B-17's wiring would supply a German fighter squadron for a month. These were advantages not of design, but of fundamental resource availability. Major Heinz Baer, who had fought in every theatre, offered a soldier's assessment. "We can destroy 10, 20, 50 of these bombers in a raid, but if they build 60, 70, 100 to replace them, we are bleeding ourselves white for nothing. This is not war, this is arithmetic, and the numbers are against us." The crew quality revealed by interrogations added another dimension. These were not professional warriors, but civilians in uniform, students, farmers, clerks, mechanics. Yet after 6 months of training, they could operate these complex machines effectively. America had industrialized not just aircraft production, but aircrew training. They were producing pilots as efficiently as they produced bombers. June 12, 1943, the captured B-17, now coded DL+XC, was displayed at an exhibition at Lurtz Airfield alongside other captured Allied aircraft, P-47 Thunderbolts, P-51 Mustangs, P-38 Lightnings. German pilots studied them all, but the B-17 drew the most attention. It represented not just a bomber, but an entire production philosophy that Germany could not match. By September 1943, when Wulfe Hund was transferred to KG-200 for special operations, the daylight bombing campaign was intensifying dramatically. Formations of 100, 200, 300 B-17s appeared over Germany. Each raid validated the fears born from that first intact capture. The bombers absorbed tremendous punishment before falling. Their formation defensive fire was overwhelming, their discipline unshakable. The improved models kept arriving through crashes and captures. A B-17G examined in late 1943 showed chin turrets with twin .50 caliber guns, eliminating the frontal vulnerability German fighters had exploited. The Americans were responding to German tactics faster than Germany could develop new ones. The feedback loop from combat to factory to combat was measured in weeks, not the years. German development required. Training revealed another American advantage. Pilots trained in the safe skies of Texas and Arizona, accumulating 200 flying hours before entering combat. German pilots by late 1943 entered combat with 50 hours of training, their airfields under constant attack, fuel rationed, instructors pulled into combat units. Quality was declining as quantity decreased, a death spiral that could not be reversed. The engineering culture revealed by the B-17 went beyond aviation. It implied education systems producing thousands of competent technicians, industrial coordination across a continent, financial systems funding massive endeavors, and social organization allowing rapid mobilization. Each B-17 was evidence of a functioning democracy mobilizing unprecedented resources. The contrast with German production was stark and depressing. The Heinkel He-177, Germany's attempt at a heavy bomber, had taken 6 years to develop and still didn't work properly. Engine fires were common, structural failures frequent. Only 1,169 were built, each slightly different, each problematic. Boeing alone had produced over 6,000 B-17s by early 1944, each identical, each reliable. By spring 1944, American bomber streams of 500, 700, sometimes 1,000 aircraft were devastating German cities. The Luftwaffe achieved 10% kill rates at best, unsustainable for the Americans at their production rates, catastrophic for Germany in irreplaceable pilots and fighters. The air war had become a mathematical certainty. Major Heinrich Erhard, visiting one of the captured B-17s being used for training in early 1944, made a bitter observation. We train against this aircraft, learning its weaknesses. But for every weakness we discover, they build 10 more bombers. We are perfecting tactics against mathematics. The strategic materials situation had become impossible. The synthetic rubber in the B-17's fuel tanks, the high-grade steel in its structure, the precision instruments in its cockpit, all represented technologies Germany had pioneered but couldn't produce at scale. America had taken German inventions and industrialized them beyond German imagination. D-Day, June 6, 1944. The prophecy revealed by that first captured B-17 was fulfilled completely. The skies over Normandy swarmed with American aircraft. B-17s had systematically destroyed Luftwaffe airfields, fuel depots, and repair facilities across France. German fighters that should have attacked the invasion were destroyed on the ground, or desperately defending the Reich itself. The psychological impact on German morale was devastating and permanent. Pilots who had been told they were the world's best discovered American teenagers in mass-produced aircraft could match them. Ground crews who prided themselves on maintaining complex aircraft discovered American simplicity was superior to German complexity. The entire construct of racial superiority died examining American industrial output. By late 1944, crashed B-17s had become a primary source of aluminum for the Luftwaffe. The Americans were inadvertently supplying their enemies with raw materials through their losses, yet still outproducing Germany by margins that defied comprehension. They could afford to lose aircraft as a form of material aid to their enemies. April 10, 1945. The last captured B-17s, including what remained of Wulfe Hund, were destroyed at Oranienburg by American bombing. But their message had long since been delivered and understood by those willing to see truth through propaganda. The war had been lost not on the battlefield but on the production line. After the war, Adolf Galland would write, "The captured B-17s were our first real contact with American industrial reality. Everything we thought we knew was wrong. We were artisans. They were industrialists. We were fighting the last war. They were fighting the next one. Erhard Milch, during his war crimes trial, reflected, "When I saw that first intact B-17 in December 1942, I knew the war was lost, not because it was a superior aircraft, but because it was proof of superior production. They could build faster than we could destroy. That is the mathematics of modern war." The German officers who examined captured B-17s experienced something beyond technical education. They experienced the collapse of an entire worldview. Nazi ideology had promised German technical superiority, racial advantages that would overcome material disadvantages. The B-17 revealed this as complete fantasy. American democracy and industrial capitalism had produced a war machine that German fascism couldn't match. The examination records, preserved in various archives, show that over 200 officers and technical specialists inspected captured B-17 at various locations between December 1942 and war's end. Their reports, memoranda, and diary entries reveal a consistent theme: recognition that Germany faced not just military defeat, but systemic inferiority in the fundamental basis of modern warfare, industrial production. Some drew the logical conclusions. Oberst Hannes Trautloft argued for negotiated peace while Germany still had bargaining power. Major Werner Streib pushed for revolutionary changes in production methods. Oberingenieur Kurt Tank began designing aircraft specifically for simplified production. But these voices were drowned out by ideology and inertia. The Nazi system couldn't admit its fundamental premise was wrong. The human factor proved equally significant. American bomber crews were volunteers, citizens who chose to fight. German crews by 1943 were increasingly conscripts, forced into service. The Americans fought to end the war and go home. The Germans fought because they had no choice. This difference in motivation showed in everything from maintenance quality to combat effectiveness. By war's end, B-17s had dropped 640,036 tons of bombs on European targets. Approximately 4,750 B-17s were lost in combat, yet production never faltered. Boeing and its partners built them faster than Germany could shoot them down, validating every pessimistic assessment made when that first intact B-17 arrived at Rechlin in December 1942. The technology transfer, though unintended, was significant. German engineers studying captured B-17s learned about turbocharging, high-altitude operations, modular construction, and systematic redundancy. These lessons influenced post-war German aviation development, though by then it was far too late to matter for the Third Reich. The captured B-17s were messengers from the future, showing Germany the nature of industrial warfare. Those who understood their message knew the war was lost by early 1943. Those who refused to see continued fighting until Germany lay in ruins, defeated not by superior strategy or courage, but by superior production capacity. An unnamed German technician who examined the captured bombers left perhaps the most eloquent summary in his personal notes. "We looked at every rivet, every wire, every instrument. We found no German superiority anywhere. We found only American efficiency, American abundance, American confidence. They built this bomber knowing they would build thousands more exactly like it. We built each aircraft as if it would be our last. Perhaps that was the difference. They planned for victory. We hoped for survival." The B-17 Flying Fortress proved its name correct, though not in the way its designers intended. It was not merely a fortress in the air, but a fortress of industrial might that no amount of German courage, skill, or determination could overcome. The real fortress was the American factory system, turning out bombers with the same efficiency it had once produced automobiles, demonstrating that in modern war the assembly line was mightier than the warrior. The examination of captured B-17s was the moment German officers stared into the face of modern industrial warfare and realized they were still fighting with the methods of the past. The B-17 was America's announcement that the age of warrior elites was ending, replaced by the age of mass production. Germany heard the message but could not change in time to matter. The aircraft existed in photographs, sitting on German airfields with Luftwaffe crosses painted over American stars, captured giants that revealed not American weakness, but German inadequacy. They were physical proof that the war was already lost, sitting in plain sight for any who had the courage to see it. In their aluminum frames and mass-produced components lay the death certificate of the Third Reich, written not in words, but in the universal language of industrial supremacy.